Hello, F-sharp, and welcome back. Let's continue our journey on introducing you to the features of the F-sharp language. Now, today what we are going to talk about is interfaces. Interfaces are very common in .NET code, and F-sharp has great support for them. Now, my opinion on the use of interfaces will likely be different from a vast majority of the community. And the reason for that is I am often dealing with high performance scenarios where I want code to run as fast as possible. And interfaces add a level of indirection to our code so that we can abstract over the shape of types. That indirection has a performance penalty. So you won't find me using them very often in my performance critical code. Now, there are some scenarios where I think interfaces are fantastic, and I will discuss those as we go along. But some of you might be saying, like, Matthew, wait a minute. I see you using the for loop all the time, the for each loop in F-sharp, and then you see you using sequences, and like that's all built on the IEnumerable interface. So like, what do you mean that you don't like to use interfaces very much? Well, I want to clarify something about .NET code. Now, there are some things that people say about like, this is how .NET behaves, but then when you start digging into it, you're like, wait a minute. I'm not so sure. And one of the things that really surprised me is when it comes to IEnumerable or sequences in F-sharp, because the sequence SEQ in F-sharp is an alias for the IEnumerable interface. .NET code doesn't necessarily use an interface in all of those scenarios. So even if you are using a for each, that doesn't necessarily mean you're paying the penalty of using an interface in that scenario. Let me illustrate what I mean. And we will get to interfaces here really quickly, but sequence is so common, I want to clear up some understanding so you don't live in the ignorance that I was dealing with. So I'm going to define a numerator here and say, hey, max value 10, and let mutable cur value equal 0. And if you are at all familiar with how the IEnumerable interface works, the IEnumerable interface is something that returns an IEnumerator. And an IEnumerator has two methods on it, and one of them is the move next, and the other is current. And I am going to do something that looks a lot like implementing an IEnumerator, but is not in reality, but it's still going to work. And that is something that I want you to be aware of as we go through this. So notice I have defined a class here. It is called myEnumerator. It does define two methods, move next and current, but I have done nothing here to say I am implementing an interface of any kind. Okay, now I can also say my collection and say like, hey, my collection is something that says get enumerator, and it's going to return an instance of my enumerator. Oh, and I have to have an equals here. At no point have I said anything about interfaces here. At no point have I said anything about IEnumerable, not at all. But if I create an instance of my collection equals my collection, create a new instance of it, and say, hey, for x in my collection, do print function, and I just wanted to print out that value. Again, at no point have I said anything about interfaces. I have not opened system.collections.generic at all, but if I run this, it'll work. And it prints out the values 1 through 9. And that is because the .NET runtime uses a bit of duck typing in this scenario. If a class has a method, which is getEnumerator, and that returns a type that has a moveNext method and a current method, it will work with these for loops. So a lot of the time when you think you might be using well, not a lot of the time, but There are scenarios where you think you might be using an interface, but because of performance reasons, the CLR is optimizing things for you. You might be tricked. So just because you see me using these for loops and stuff, don't assume that I'm actually using the IEnumerable interface. And so I'm wanting to be consistent up front when I talk about performance scenarios and what I care about, what I don't care about. But okay, let's talk about interfaces. Now that we got that out of the way, how would we define an interface in F#? Well, fortunately, it's quite easy. And what I'm going to do, I'm going to say type IAnimal equals, and then I'm going to say, like, for this interface, what needs to be a part of it. And I'm going to say abstract member name string. So I am declaring an interface, and I'm saying it has a property on it that is called name, and the value it returns is a string. I can add another thing, which is, hey, you gotta have to have this talk method. And that is something that you provided a string and it returns unit. When I hover over that, yep, we have an abstract member. It's called talk. It is a method that takes a string and returns unit. Okay, so how would I go about using this interface? Well, it's quite easy. So I'm going to define a type chicken string. Oh, gotta have that equals there. And my chicken class, I'm going to have two things on it. I'm going to have member name equal to name. And I'm going to have a member which is talk. And it's going to take a string. And it's going to say print function. And then it'll say like, hey, my name is, and I want it to print out the name that it has and also a print function. And it's going to say cluck. And then it's going to say the words that you said. Hey, let's change this to words. Words. Okay, that makes it a little bit more clear. And something I realized that I thought was funny, I was looking at the distribution of people who actually watch this channel, and I came to realize that a vast majority of the people who watch this channel are not based in the United States. And so English is likely your second language. And United States English has certain words in it, things like cluck, and that's the word that we think a chicken makes, that we think that's the sound that a chicken makes. I'm not sure if other forms of English use the same sounds. I watch a lot of anime, and I find it funny that the sounds that Japanese uses for the sounds that animals make, they're not the same. So to clarify, for those of you where United States English is not your native tongue, when I use these words with these animals, I'm typically referring to the sound that animal makes in the form of English that I speak. So hope that clarifies some things. Okay, so I have this instance of chicken, but it's not implementing the IAnimal interface yet. So let's go ahead and do that. So I'm going to say interface IAnimal with member cname. And what I'm going to do now is I'm going to implement the properties and methods of this interface. And I'm doing that by saying, hey, I'm going to do an implementation of this interface, IAnimal, and now below that, I'm going to indent and say, okay, this is how I'm going to implement those things. And I can use the self-identifier to say like, hey, this C is referring to an instance, the particular instance of chicken. And so that is equal to c.name. And then I'm going to finish this other member, and we're going to unpack it a little bit. Talk words equals c talk words. So what is this doing? I'm declaring that I'm going to implement the interface IAnimal. Below it are the properties and methods, the implementations. And here I'm saying, hey, the interface member name is going to redirect to this instance method. And C here is the self-identifier. It is returned to the instance of chicken that is implementing this interface. And I'm saying, hey, and I'm going to just change this instance of chicken. So that's actually way too wordy, but I'm wanting to be very clear about what is referring to what. So this is just the self-identifier. This is the name of the abstract member that I'm implementing. And then over here is the code that it is calling to implement that member. I'm going to undo that rename. And the same thing, I have the self-reference. I'm referring to this instance of chicken. I'm using C to do it. Talk is this abstract member in this case. And that talk is going to take an argument, which in this case is string, and then I'm basically going to redirect that to call this instance of talk with those words. And I'm going to do a rename here. I'm going to say instance talk, and I'm going to say instance name. And that rename didn't quite work, so I'm going to go ahead and patch that up to make this a little bit more clear about what I'm referring to. So my apologies for that. So these are members of the instance of chicken. Here I'm declaring that this instance of chicken is fulfilling this interface. And the way it is doing that is saying for this abstract member name, redirect that work to this instance member. Same thing with this abstract member talk. I want you to redirect that work to this instance member. So it's basically saying the way I'm implementing this interface is by referring to these instance methods. And you could be referring to other things as well, but that is how I'm actually implementing that. So the signature on the right has to do the work that this said it was supposed to do. And so this is why we have this performance penalty associated with using interfaces, is because it necessitates some amount of indirection. Now, again, the CLR knows that this happens, and in certain instances, it can actually do a lot of inlining and called de-virtualization is the term. So it can remove that penalty for us. But without those optimizations, there would always be this performance penalty of going through the interface. Again, the CLR is doing everything it can to avoid that, and so it might save you from it. It might not, and that's where all my performance-related content that you can go and look at and being able to diagnose and like, am I actually paying this penalty or not? Is there something that I could do to remove that indirection, that virtualized call? Okay, so I'm going to put these names back because this is very common. You would often see something like that where I have the instance names and then I have the interface which refers to the instance. I can of course define another one. So I've defined a chicken, and I could also say, hey, you know what? I'm gonna have a turkey here, and turkey, instead of saying cluck, says gobble gobble, as turkeys do here in North America. And yeah, turkey also implements the interface iAnimal. And let's go ahead and use it. So I'm going to create an instance of chicken. So let chicken, and chicken's name is going to be Clucky, of course. And then I want to say, like, you know what? I want to write a function that takes an animal, iAnimal, and then I want to call the interfaces, methods, and properties. And so I'm going to say, hey, print function, and say a dot name. Come on. And I'm also going to call the talk, a talk, and I'm going to give it words to say. So I'm going to go ahead and run everything above this line first. So we've brought all of that stuff in. I'm going to create my instance of chicken. Its name is Clucky. And then I have defined this function, which does not take a chicken. It takes an iAnimal. It takes this interface. And so I can call my animal function with my chicken. And then it's saying, like, hey, my name is Clucky. Cluck, words to say. And I can also do this with a turkey. T equal turkey. And turkey's name is going to be Gertrude. And again, I'm going to call animal function with the turkey, and then say, my name is Gertrude, gobble, gobble, words to say. And so, yeah, this function is now able to work with any object which implements the I-animal interface. So, and our classes can implement several different interfaces if we want them to. We can use generics with interfaces as well. But there's a couple other things that I wanted to cover in the time that we have together. There is a fantastic feature of F#, which is an object expression, and it plays very nicely with interfaces. So let's say we wanted to create an instance of an interface, but we didn't want to go to the trouble of defining a type that implemented that interface. Well, we can do that. Say, hey, let my animal equal, and I'm going to say new I-animal with, and I'm going to say, you know what? This instance of I-animal, its name is going to be Grace. And member a talk words equals, let's say, hey, print function, my name is, and then have it fill in its name. And then another print function for having it say the words that we give it. What did I just do? So this is the beauty of F# and the idea of everything being an expression and returning an expression, where we're saying, you know what? I don't want to go through the effort of defining a new type and then having to implement that interface. I just want to create something that looks like this interface. And so I'm just going to put pieces together to fulfill this I-animal contract. I call this kind of Frankensteining a type. There's probably nicer words to use, but yeah, let's go ahead and prove that this works. Like, okay, I just created an instance of my animal. It is something that implements the I-animal interface. And so, yeah, we could use it with animal function, my animal. And it says, yep, my name is Grace, words to say. So there you go. A lot of the times let me back this up. So this is where I love interfaces. When I'm writing code and I want to abstract over something, it often has to do with testing. And specifically, testing that my code behaves the way I want it to when it has like a dependency on an external resource. So I think like a database, something like Kafka, some external API call. Anytime it's kind of reaching out and the possibility of failure is there, I want it to fail the way I want it to. And when I want to set up unit tests to test that behavior, I don't want to have an instance of my database up and running on the same machine. I don't want to have a Kafka cluster up and running to be able to test things. I want to abstract over that dependency. And then what I can do is I can implement the behaviors that I want it to have. So I actually have a blog post article where I discuss this, and I'll link to that down below. But the idea is that, like, hey, I could have something where I say type I database. I know this is probably terrible. Equals abstract member save stuff, and it's going to take a string and return unit, right? And potentially you have other things on here. And I'm not, yeah, okay. So, but let's say like, hey, I have a test and I know that my database could throw some kind of exception, but I don't want to have a database having to run it on my local machine to run these unit tests. And I don't want to have to like manually create a situation where the database is going to raise the exception that I need it to raise. So what I could do is I could say like, hey, mock database base equals, say, new I database with member save stuff. And it's going to take an input. And then what it's going to do is going to be it's going to raise some kind of key. Oh man, key not found exception. I'm not sure if I have the right namespace open for this. Cool. So now what I've done is I've abstracted over like what the actual dependency is underneath my code. And now what I can do is I can use this mock database, which is just an object expression that implements my iDatabase interface. And when I call save stuff, it's going to raise this key not found exception. And so now I can just test, does my code respond to this key not found exception correctly or not? So I find this to be incredibly useful when writing unit tests that I want to run on my local machine, but I don't want to have to spin up any of those external dependencies for my code. Now, there's one other aspect of interfaces that I want to discuss, and that is the idea of flexible types. You know what? I'm actually going to save that for later. We have covered enough today. I'm looking at the time. I'm like, I don't have enough time to get into it. So my apologies for that. You'll just have to wait till next time. But thank you very much for spending some time with me today. I hope you enjoyed it and it was informative. Interfaces are fantastic in fsharp, and fsharp makes using them easy and simple. I don't often reach for them, and that has nothing to do with whether they are good or not, and it has everything to do with the type of code that I am writing. So until next time, you have a wonderful day. Thank you for spending some time. Bye-bye.